And for the final worked problem of Chapter 7, we are going to be calculating weight loss from exercising. So, if a person who normally requires about 3,000 kilocalories, and if y'all are not aware of this, kilocalories is the same, so 1 kilocalorie is the same thing as 1 big C calorie, which is how we measure our food energy content here in the US. So if a person who normally requires 3,000 kilocalories of food energy per day is suddenly consuming 13,000 kilojoules, and you can see the difference here. 3,000 kcals is about 12,000 kilojoules. And now they're consuming 13,000 kilojoules per day. That person is definitely going to gain weight. Not overnight, but the person will gain weight. So how much bicycling per day would be required to work off that extra 1,000 kilojoules? All right, I included a chart of activity over here, just so we could reference it. It says how much bicycling, and if I look at this list, I see we have cycling here, and I see there's another one down here and another one here. I think we can definitely eliminate this final option. This problem doesn't say anything about this person being a professional racer, and it doesn't indicate whether the person is doing cycling between 13 and 18 kilometers per hour or 21 kilometers per hour. So let's go with this, because this would cover more situations and be something that most people could accomplish, whereas these other two are cycling at faster speeds. So we want to know how much bicycling is required. Let's note that this measurement here for cycling is the energy consumption in watts. Watts is a measurement used for power. So I'm going to go ahead and write down the power formula. So power equals work over time. If this is asking us how much bicycling per day is required, that means it wants to know how long is the person going to have to ride the bicycle in order to burn off this extra 1,000 kilojoules of food consumed, food energy. So we need to figure out time. I'm going to rearrange this to say time equals work over power. Work is just the amount of energy we have available to us. And all of this food is measured in units of energy. So we have kcals or kilojoules, but we're going to stick with kilojoules because it's asking us about the extra 1,000 kilojoules. Okay, so T equals, well, in this we're told there's an extra 1,000 kilojoules. Again, this is a unit indicating work, so we're going to put the 1,000 kilojoules on top. And we see that the power is this value, 400. We know that because it's measured in watts, and watts is a unit for power. So when you divide this, you would get 2,500. And if you're wondering what unit goes with that, it is seconds. So if we converted that to minutes, it would be around 42 minutes of cycling that is required to burn off this extra 1,000 kilojoules of food energy. And in case you are wondering, I'll do this little conversion down here. 1,000 kilojoules, if we convert this to big C calories or kilocalories, it's like this. 1 kilojoule is 1,000 joules, and there are 4,184 joules in 1 kilocalorie, so that's about 239 food calories that this person is eating extra per day, and it would take about 42 minutes of cycling to burn that off. I hope that made sense. That's the last problem for this chapter.